Hello, good morning. I think it's still morning. Thank you for coming to my talk, firstly. Let me introduce myself. I am Ana. I'm a custom application development enthusiast. I am passionate about working with Java frameworks, IBM Cloud. I enjoy experimenting with Kubernetes and Helm. It's going to be about this in the talk today. I'm sharing some of my experiences within the Bucharest software craftsmanship community back in my home country, in Romania. And the reason why I chose this topic today is because I believe that in our job, we're not having the same practices as we used to have as developers. We are interested also into what's happening beyond our application code or in what we coded for today, for that day at work. We're also interested in what our colleague from DevOps is doing, how he's handling and is taking over our application furthermore. And this is why I want to tell you a few things about some good and bad stuff that can happen both in the application code or in the Kubernetes side. Those being said, let's talk a little bit about the magic behind the pod. Sometimes people believe that working with Kubernetes is difficult, which might be true. That those that work with Kubernetes are doing some kind of magic over there, and when the magic is not working as expected, well, it's not so much magic anymore. It's more of disappointment. Because of this, I would like to introduce you a few concepts that I'm going to work with in the presentation today. So, firstly, I'd like to talk to you about the pod phases. The pod phases, you can also see them if you're playing a little bit with Kubernetes. So, the first one is pending. It means that the pod is accepted by Kubernetes system, but all containers are not created. Either the Kubernetes scheduler is scheduling the pods on specific nodes, so it takes some time on scheduling them on specific nodes, or your pod actually is in the downloading phase. So if you're using large Docker images, you're going to see the pending phase for quite some time. This is why that pod with keep the Docker images as small as possible. Now, the next phase is running. This is the desired phase for our containerized application. We want to have it up and running. This is one of the best phases that we can have our application. It means that either all containers were created or at least one container is created, running, or is restarting. So all this means that it gives a running state, a good state. Now we have the phase of succeeded. The succeeded phase is about having the pod terminated, but it exited with success. It did the right thing. Typically, you see this phase on pods that are associated with jobs or cron jobs. Those are, if the cron job or the job was successful, you're going to see your pods in the succeeded phase. It terminated with success. There is the failed phase. The failed phase is, well, the pod has terminated with not so much success. It's not that nice. We don't want that, but it exists. It can happen. Also, pretty often seen. And if none of those phases can be identified by Kubernetes, then it's unknown. It's also an option. Those being said, let's talk a little bit about the connection between deployment, replica set, and pod. So every time you are using a YAML file that it has a deployment resource, very well, the instance very well defined over there, and I'm going to use deployment resources also in my examples today. What you're doing is actually you are asking kindly to Kubernetes, if you're using apply, of course, you are declaring that you would like to have created a deployment resource which has three important pods: the selector, the pod template, and of course the number of replicas. Based on that deployment resource, the replica set is instantiated. Same selector to know the connection to which deployment the replica set belongs to, a template, and of course the spec'd out replicas based to 2. The replica set is the one that is taking over and is making the amount of pods that is needed for your your deployment to run, to be successful. Those being said, actually, I think I'm gonna exit this. And I'm going to detail a little bit about our playground. Yep. So I'm going to have a very simple Spring Boot application today. It's called it's a modified Hello World. Its application has a simple controller, nothing very fancy. And of course, it has a health indicator that's implementing the reactive health indicator. So it has some tests also here for my Hello World controller. And yes, some resources, some customization defined in the application properties. So nothing very, very fancy. We keep it simple, right? Those being said, what can happen even to a simple application like this one, meaning one with this kind of application could not feel well. So in order to determine the health of an application in Kubernetes and actually your application health of your developers, what you're going to create, you're going to create a health check. So you're going to create such a class as I did, the health indicator, which is typically an endpoint that you're using for making the readiness probe and the liveness probe. Some people prefer to put both the liveness and the readiness probe on the same URL. I would advise to keep it separately. The reason being is because readiness probe is assessing if the container is ready to accept traffic, while the liveness probe is assessing if the container should be restarted. So they do different things. In this case, you should check them differently, and if they're feeling okay, differently. Also, at this moment, Kubernetes is supporting 3 mechanisms for working with probes. It's the one to run a command inside the container, making an HTTP request against the container. I think this is the most often that you're seeing, and opening a TCP socket against the container. But a probe has a number of configuration parameters, and these configuration parameters can also induce the give up state. So, depending on how you juggle with these configuration parameters, you can make your probes to give up at some point in time. And if the readiness probe is giving up, it means that no traffic is routed to your pod, which is very bad. So you're losing requests from your users. If the liveness probe is giving up, then the pod will be restarted. You'd say that's not a bad thing, it's going to be restarted. However, this happens really, really often for a system because you did not put your parameters in a correct way. It's not very nice feeling. Now, those being said, the readiness probe is typically used for systems, for example, for microservices that are integrating with third-party services. Taking, for example, if you're having authentication, right, and you're using authentication, and if that dependent service that you're using, it has a temporary increase in latency, then your readiness probe might not behave as you have defined it in the beginning. So all the time when you're dealing with third-party services, there is the opportunity to have such an unexpected behavior, and it happened, I've seen it. Now, the solution for this kind of situation is to set the timeout longer than the maximum response time of that dependency. So you should assess, or you should know for that third-party service what's the maximum response time that's going to be, so you can adjust your timeout for your readiness probe as defined. So let me, one sec, need to exit presentation mode. Go to my IDE, health. So the deployment part. As you can see, my first image, the Hello World 1, I have set it up to start with 30 seconds delay. So this is why I have configured for my readiness probe to the timeout seconds to 30 in order to know when I should try again to reach to reach my container. So this is one way. Another way to avoid this kind of situations is to increase the initial delay seconds. However, if the temporary the temporary delay, that thing is happening not so often. Increasing the initial delay seconds might be not a good option. And secondly, I should modify this 1, 2, 3. So also pay attention to the failure threshold, because you want to have an appropriate number of retrials to try again on that readiness probe. Now, if you really want to make sure that, well, you're going to know what's going to happen with your container, you can also use these two, the termination policy and termination message path. So if something goes wrong when with your deployment, actually with your pods, and God forbid, they fail, what it means that by setting these is that I am redirecting the last piece of the termination, the failure. I'm redirecting it to a custom message path, so a custom log that I can ensure and find while searching within my log. So it's much easier to find a specific log when you know it's failed. These two are really good if you want to make sure that you're capturing your failures in a specific place. And of course, I have my liveness probe. That's pretty typical on actuator health path. So let's make a small deployment and see what's going on. So perfect. Okay. So, wait. I think, yeah, my token expired. It's going to dev. So hello world, you see the readiness probe failed. The connection is refused. So right now it's taking some time because my first trial was not successful. But the timeout is set to 30. I know that I can come back. And now my deployment is okay. Everything's fine, everything's green. The application is deployed. The pods are running fine. So this is really great. Another situation that can happen, and there's a kind of question regarding this one, is the frequency of the readiness probe impacting the failure threshold count? So, well, if the container evaluates that shared dependency in the readiness probe, yes, there is a dependency between those two. So meaning depending on the frequency of the readiness probe that is determined by the period seconds parameter, you may want to increase the failure threshold count. So the idea is to avoid failing the readiness probe prematurely before correct that thing and the latency is no longer there. So the right way to do things is to pay attention to the timeout and also correlate the period seconds with the failure threshold count. This is the recommendations for the readiness probe. For the liveness probe, well, the biggest question that everyone has is, how can I know that the liveness probe verifies the responsiveness of an application? Because I'm actually invoking a different endpoint than like the real endpoints that the users are going to use. So how do I know that that's going to happen all the time, the right thing? Sometimes people are coding the health endpoint once and not coming back over that one, even though that maybe some things have changed in the functionality of that microservice, and you might want to come back and assess the health part. Now, for this one, the idea would be to observe your deployments and your restarts and the failures. So having a monitoring system in place and looking weekly, I would recommend, to how that system is behaving and to the reports that are being sent to you on, well, how the deployments were, if there were any restarts, why those restarts occurred, and what failures are there. Well, it's a good way to assess if the liveness probe is actually doing the right thing. Secondly, there is the idea that if the container startup latency is changing over time, this is very important for that, restart, the pod restart part. Because if the startup latency changes over time, and this can happen because, I don't know, the network topology has changed, or the fact that there were some other changes in your code, so it takes a little bit longer to start up the container. What would be appropriate to do in this case would be to juggle with the initial delay seconds and the timeout. So, look at how rapidly would you like to start that container, and also to the timeout. So correlate these two really well, so that you won't end up, having excessive restarts to your application. Next thing that I want to talk to you about is why am I forbidden access? So if it happened to me because I joined a new project, I had an access to a cluster, I could have seen it, but I couldn't have done nothing in the namespace that I was supposed I can do things. So let me tell you a little bit about the role-based access control at Kubernetes level. So Kubernetes is working, well, you want to have control over resources, deployments, pods, as you see earlier, secrets, config maps, you name it, to the actions that you can do upon those resources, like create, edit, delete, list, watch, get, and of course, the API versions of those resources. And in order to control those, you have two roles possible. So the first role would be a role. A role is giving you access only to a namespace. And the cluster role that gives you access at the level of the entire cluster, so multiple namespaces. In order to bind the roles to the subjects that are actually going to have those authorizations is the resource called cluster role binding for the cluster-wide, and the role binding for the ones that are namespace level. Typically, users are us, the people. Service accounts are being used in the deployments, are being used when this kind of account is namespace, is intra-cluster, and it can authenticate against the API. And the last one is the groups, and these are referred for multiple accounts, and like, for example, cluster admin. And those being said, the question is, how can permissions for a user be validated? So one way of doing that, let me share my user with you. So I have created my own role called Deployment Manager. It doesn't do much. It has access only at the namespace dev. Has access only to the API groups, extensions, and apps. Only on the resources that are deployment, and it can use only the verbs get and list. So we can get and list something from that namespace. Furthermore, I have created a binding object. The role binding, I've created a role binding because I have access only to a namespace. So my role binding, called it Deployment Manager binding, also the namespace of dev, is related to the subject, well, user, Ana, myself, and it has the role referenced as the one that I've created earlier, the Deployment Manager. So I have created these two, and I think I've just created a deployment in dev. So if I want to see if I have access to that one using my user, Ana, what I can do, I can use kubectl RTH, can I get deployment -- as Ana in the namespace dev. Yes, we were expecting that, right? Now, can I create a deployment if I were to log in as Ana? No. So this is how you can check if you have access to specific namespace with your user. So this is one way to validate that. Another way of validating permissions for a user is to have enabled the audit logs, check if that user should have access to that to that namespace, and to grant the proper role or cluster role to that user. In this case, I'll just put the command for the cluster role. So this is the other way around. Now, the next topic I want to bring up to you is the fact that, well, pod is running, but it's not running what I was expecting or as expected. So the question is how to validate what is inside a pod. By default, if you're issuing kubectl apply, that deployment of yours will be validated. However, if you are intervening at the definition of a resource from, for example, from this beautiful interface here, and you're making an edit and you get away with it, and it's a mistake, syntactical mistake, it's not going to be validated, and it's not going to be, wait a moment. Okay, sorry about that. It's not going to be validated. And what you can do in these kind of situations, and it happened before, like syntactical mistakes were done, it went up, it was applied, nothing was believed as good. What happened is you get the pod YAML, so with the kubectl get the pod and export it, and you validate that locally. So you can use the validate locally and you can see what's going on over there. But next is, what if I want to see inside my pod? The reason being, you want to see what's going on with your container. Typically, when we are making Docker files, as developers, we are defining this called entry point, right? And we're defining it here. So you don't see it necessarily. So if you're looking through a Docker file, you know it's going to be calling an entry point script, and no big deal there. However, if things are not as expected and you want to check what entry point script you have in your pod, in that case, you're using the command kubectl exec -it. Well, first let me get in the pods. Okay. From the namespace nev /bin/ch. So I'm now inside my container, and I can see everything it has here, including my entry point. So furthermore, I can have more Linux commands done here. But most importantly, I can also copy from my container using kubectl cp. So I can copy what's in that entry point, see it in the local, what's in the entry point, troubleshooting it, and put back from my local inside the pod the right entry point that's over there. It's a mistake that can happen and is seen. I've seen it on Stack Overflow, like reported by someone. And this is why it's okay to mount a shell script inside your container. Now, another question is, how can I replace images? So in this case, there are two situations. Well, if the image tag has changed, but your deployment is using the old tag, meaning you used to have tag 4, now it's tag 5, but you haven't set the image pool policy to always. It's not okay to set the image pool policy to always, by the way. The first thing that I think you can find all over the internet is, well, change the image pool policy, put it to always. But this is going to trigger some additional cost that's not very okay if you're not modifying your Docker image so often. So another way of doing that is by using the kubectl set image and just elegantly change the image that you're having over there. So that's more likely to do it. Secondly, if the image tag has not changed, so it's still 4, but you've changed your application code, you can add your own label and patch the deployment. So what I'm referring to this, I'm not very good at writing patch commands. I'm always writing them and copy-pasting them. Is by making something like this. Typically, I prefer for emergencies using the date. It's the much safer thing. So you just patch the deployment with a dummy label, the date in this case, and voila, you trigger the recreation of the pods. Now, if you're using Helm, for example, the package manager, you have the -- recreate pods option. If you're changing other resources that your deployment is dependent when you're using Helm, like secrets or config maps, you have annotations that can trigger those, the deployment and recreation automatically. So there are ways to work around that. And secondly, if you really want to trigger a deployment and still your image has not changed in terms of tags, you can also use kubectl rollout restart that was introduced from 1.15. And is also a useful command. So there are 3 ways of working with this kind of situation. Now, the part with working with volumes, so the volumes are the most powerful way to persist your data inside Kubernetes. And one thing that is written in the documentation, and people believe that, well, is written in the documentation, it will never affect us, and we should not care about it, is the fact that the volumes cannot mount onto other volumes or have hard links to other volumes. The thing is, kind of happened to me a few months ago on this one, when I had to reread the documentation and really found this one that was the answer of my situation. So what happened was that I had 2 volumes. Let me share with you. The volumes definition, it was one used for uploading. And of course, a host path defined for it, and a persistent volume claim. And then I had a backup volume that was having the path of backup. It was pointing to that one. And then there was a small job defined that, well, it knew that it keeps using just this lovely part with the upload. So it was using just upload, but somebody thought that it would be better if it would use the mount path to home projects, not directly to the upload, to the root. When applying this, so let me produce it. Job got created. Let me go here. Yeah, it's green. It's working. It has a pod. It's okay. I think it terminated, completed. It's fine. It looks very nice. But it was having a command to execute. So if I'm going to my logs, it was saying that it could not execute the shell script from that I uploaded over there. So because of that thing that I didn't mount correctly my path, and I didn't pay attention to that, well, I ended up with this situation. A situation correct of using both volumes would be like in this one, when I'm having more complex command, and I have the mount path put correctly, so to the upload data and to the backup data. So I am directly going to the path that I've set for my volumes. I'm not just using shortcuts just because I had some common root over there. Another interesting thing to be known about volumes is the fact that the mounting operation, as you saw earlier, can mount only in existing volumes and paths. So if you're using a path that doesn't exist and you expect to be created somehow over there, it will not result in something good. A second thing that I want to tell you is to check the default storage class. So when a cluster is created, it has a default storage class, but that default storage class can be changed. So pay attention to that one, because I used to have a local deployment. I applied it in the cluster that I had in the cloud, and the result was very, very, very surprising, because it was not behaving as expected in my local, and the situation was because of the storage class. The default storage class was not the same. It took me like 2 days and the help of a colleague to realize that the default storage class was not the same. Secondly, the storage classes, in their definition, have something called provider. And those providers are depending on the provider that you're using. So if it's Google Cloud, if it's AWS, if it's IBM Cloud, you're going to find a different provider. So pay attention when you're playing with storage classes across clouds. Because sometimes you want to back up, so if you back up everything, every resource that you're having, and you're including these, and you're porting to a different cloud, you might end up with issues and you don't understand why, because I'm using the same storage class. And you can even check out the Kubernetes documentation for the slow storage class, and you'll see different providers given over there. Last but not least, let's talk about jobs. So scheduled jobs are the ones that are used for what we call in literature batches. So things that we want to run from time to time, right? And of course, we also have jobs, the ones that we want to run like one time and that's it. So I want to show you something, a very good job, perfect one. So I've said it's a great job. So this cron job, it looks really well. It's correctly syntactic. So we have green tick over here. It is scheduled to run every minute. It has the concurrency policy. Oh, thank you. Thank you very much. I forgot. No, it's okay. So this job that's defined over here, a cron job, it has a schedule to be run every minute. Concurrency policy set to forbid. The failed job history limit set to 1, so it's very restrictive. It's getting an image, correct one. Has some arguments to run that image. Termination policy set to a file, so it's everything nice. Image put policy, I've set it to always. I don't know what it was with me when I set that one. Anyway, and restore policy never. So termination grace period set to 30. So it's everything looking nice and correct. So let's go and apply it. Okay, it was created. Let's go what happened. It's green. Let's wait for a moment, like a minute, because it has to run every minute. But the good thing is green. It's done the right thing. I love the green part. Just bear with me. It's going to do something very nice. It's a great job, right? So, just more 20 minutes. And like 15. Come on. Oh, did something, has something active. Right, let's go. Let's see what, oh, it makes a lot of bad pods. It says failed to start container, error, and it keeps creating pods, even though that I've limited it, right? And it was a good job. So in this kind of situations, when this is running infinitely, there are two solutions for this situation. Either suspend the job, and for this one it's using this command. Just copy paste it. Oh. I didn't use the namespace. So it was patched. Come on, stop. You should stop. 1, 2, 3, 4, 5. I shouldn't create more. I patched it. Yeah, it stopped. So suspended it. So that's one. Now, there is another way. That's my favorite. About 30 February. Another way is to patch the schedule with a date that is not going to exist like ever, like 30 February. I don't think that 30 February exists in any calendar. So it's kind of a way to stop things that are running like that. The thing is, even though that I've set so many limitations over there, my job did not complete, and it was trying and trying again to do what it's supposed to do. The reason being, because my great job is using this argument here, bin get. The correct great job is this one. That's using this args here. Let's use the correct great job. It has the same name. Yeah. Oh, forgot. Okay, I deleted this one. Now, let me apply the correct one. Cool. Again, we have to wait like 1 minute. No worries, there's enough time. Another way to do this, not just correcting the, command, would be to have another stopper. So the modified one is to have also the back-off limit set to 0. So you can patch with the back-off limit set to 0 and you stop it. This is going to stop it again. So this is another way of correcting things that were not okay for these kind of commands. So if you want to really stop it, you patch it, and then you want to correct it with the right command. So you go over here. Yeah, so I think it should start having something active. Okay, it has the great hello world, terminated, completed, it's green. It has the right things over here. And in the logs, well, not messages yet. Oh yeah, I haven't written a message in it. I should have done it. But the thing is that the command was executed correctly because I modified it. So there are ways to stop these jobs by all the time patching what you're having over there. So the idea would be to suspend the job firstly, set the back-off limit to 0, but if you didn't have also the restart policy set to never and the concurrency policy set to forbid, also use these three. So use these three in the combination to stop it. So those being said, there are a number of ways to stop things that are going badly, and afterwards inspect what's going on over there, reproduce it on your local, and fix the situation. I have like 12 minutes left, so I'm going to tell you a little story from the Helm side. It happened a few months ago. So for an application, I was using some charts that are from a third party that I was considering always as stable. So I was having a third-party repository that I always considered charts over there with the latest version to be the latest and the greatest. This is the best thing. And always considering that when you are making a deployment is kind of risky. What had happened is that at some point in time, I had a discrepancy. I have a successful deployment in a lower environment and an unsuccessful deployment in an upper environment, all the time looking to the third party's table. What I found over there is that there was a small issue introduced with a merged PR And this is why I had the discrepancies between those deployments over there. So sometimes when using stables, things that you consider stable from third parties, make sure that they really are stable. And the morale here is that looking on Google, the solution given was altering something in the scheduler. It was really, really complex, and it didn't have anything to do with the fact that there was a merge PR. The way that I found it out, I just looked into the repo, saw that there was a new PR, comparing it with the day before, and that was the only difference happening over there, no other stuff. So I thought that, well, if it worked the day before, probably this is the problem, and I have just used what I had from the other one in order to make a deployment in the upper environment, waiting for a fix for the stabilized one. So sometimes Google is not giving you the best answers, and try to understand the issue that is happening over there on your own. So in using some of the commands and the stuff that I presented today. I want to tell you that problems with containerized applications can occur all the time. Also, in Kubernetes, I think there are endless issues that you can bump into. There is even an interesting website about Kubernetes famous failures, people that have shared post-mortems from their stories, from what happened to them. It's a very great page where you can learn what happened to others, not necessarily mistakes done by engineers, but things that can happen that you're not thinking when you're designing a system, and then you're getting it, and when you're scaling it, and you're having everything at a larger scale. So the idea would be, when you have a problem, worry about that problem and do not blame someone. So do not play the blame game in your team. Those being said, I want to thank you, and I want you to please rate me so I can get some feedback from you. And I think we have 9 minutes for questions. If you have any questions, please. Yes?
Can you tell something about improvements in the VM for running Java or container?
Improvements in the VM. I can give you a good article about that one. I have one. So if you want, after this one, I can share with you. I am always following that one for that one. Other questions? Yes?
When you showed the cron jobs that like appeared to work but didn't work, it was having a green check mark. Could you do anything in the job definition to show errors in pods or jobs or whatever more clearly?
The thing is that when you're looking at the definition of the pod, that one is checking for the syntax, it's not checking for the values. The problem there was the value, which is not the key that we were having in the definition. This can happen all the time. And for example, there was a version of the cron jobs where you could have defined some of the keys, some of the parameters lower than in the template, lower than you're supposed to do it, and that generated a real problem and I've read it over the internet. It generated a real problem for a company. Because again, they couldn't stop the job and they didn't understand what's wrong because it seemed correctly. That was but that part is deprecated. So I found it in the documentation of Kubernetes. It's deprecated, so nobody would run into the same problems. Another thing is that well, you can always make mistakes, and sometimes people are out of panic because you're trying to stop the bleeding. Are just running directly. So the worst thing that you can do is go directly with the black, with the Vim and everything, and modify things over there, because you can run into human mistakes. So I can swear that I love to work with the IDE because it shows me where I'm mistaken than from the command line. But I've been recently through a certification where I had only the command line to work with resources in Kubernetes, and it was really fun, but I've made a lot of mistakes. So the thing is that the way that I had some spare commands to help me to troubleshoot what I did over there, because I had to touch some points, and when you are in a hurry and you're trying to type things, you're kind of eating letters. So it happened to me, and I know it was not very, very nice. And I mean, I felt the pressure then because I had to finish in time. So it's the same as in real life. You have the pressure to stop what's going on over there. But as I said, most of the time, the values, I think that you can try to do some custom validation on your side, but it will be too much of a burden if you ask me. Because imagine a large system, you would have many of these YAMLs seen here, and it's not easy to make a customized validation for everyone. And these are just simple examples on what can go wrong. Any other question? Okay. Thank you very much. I'm waiting for your feedback, and enjoy DevOps.